All right, everyone, let's talk linear programming. I'm going to tell you right now, there is a ton of vocabulary here that seems really scary, and if you just say the words, it's amazing. So I'll give you the gist of it. We are going to maximize an objective function by testing the vertices that are formed by our constraints. That's called the feasible region. So the vertices of the okay, let me use those words, break them down. Once you get used to it, it's not that big of a deal, but it sounds very intense. Okay, this is called, I'm going to use this so you guys can read my writing because I can't write very well on that thing. Process of maximizing or minimizing an objective function. This is called linear programming. So linear programming is this activity, and this is a bit of a side shoot from the systems of equations stuff we did earlier. When you are graphing multiple inequalities, the inequalities that you create limit your possible x and y values. If they're limiting things, they are called constraints. So these are finding the constraints. And for today, I will give you the constraints. There's no word problem component to it, but tomorrow we will write constraints. The set of points limited by the constraints, the set is called the feasible region. Feasible. Feasible means it's possible. It can happen. The feasible region is all of your ordered pairs that will satisfy all the constraints. And the function that you're trying to maximize or minimize is called the objective function. And usually, if you're trying to maximize or minimize something, it's profit. How do we make the most money? So we're trying to figure out how to maximize something that is independent of the constraints. And the maximum and minimum for the objective function will always occur on a vertices on a vertex of the feasible region. Okay, so we're going to look at the feasible region and we're going to find its vertices, and we're going to graph using Desmos for this activity. So make sure you have Desmos handy, and I do. So let's get moving. All right. So first thing. Find the maximum, minimum. Here's the objective function. One thing you want to remember, you don't graph the objective function. You do not graph the objective function. That is not something we're going to put on the graph. We are going to graph these four constraints. And like I said, we're going to use Desmos for it. So let's get into Desmos. I'm going to say, I need to get my tab up, x is greater than or equal to 0. So the first thing it's going to do is it's going to shade all the numbers where x is positive. What's my next constraint? Y is also greater than or equal to 0. So y is greater than or equal to 0. Y is greater than or equal to 0. So you can see we're only focusing on the first quadrant right now. I'm going to get rid of these until the end. Okay. X plus 2y is less than or equal to 16. X plus 2y is less than or equal to 16. Okay, there you go. You can see the x-intercept is the y-intercept is 8 and the x-intercept is 16. Again, we just talked about this. 16 and then 2 times 8 gives you 8. That's why those are there. Hide that one. What's my last one? 5x plus y is less than or equal to 35. 5x plus y is less than or equal to 35. Okay. So first thing I'm going to do is graph them and see if I can find the overlap between all four. And let's see. I'll do one at a time. So purple, there you go. Okay. And then green. So right now, the feasible region is right here with those intercepts. And it looks like that's going to actually be all four. So the spot that's overlapping all four is what we're looking for. So here and there's where those guys intersect. And then we have these guys. So I'll see if I can click all four of those. Those are the 4 points at the end of the feasible region. And what I'm going to do is I'm going to just screenshot this so I don't need to keep coming back here. Okay. Oh, that didn't, come on, keep the order pairs. There we go. Okay. So when I graph it, what I do is I find where all four of them are overlapping. That is called the feasible region. So if I say list the ordered pairs of the feasible region, we have 0, 8, 0, 8. We have 6, 5. We have 0, 0, and we have 7, 0. 7, 0. There we go. Okay. Those are the 4 vertices of the feasible region. You graph it and you find where they overlap, and those are the 4 vertices. What we said earlier is the maximum and minimum for the objective function will always occur on one of those vertices, vertex. So I need to now plug those in to the objective function. The objective function is when we didn't graph. That's right here. So what I'm going to do is plug in those tests. So it's 4x plus 5y. So 4 times x is 0 plus 5 times y is 8. I'm plugging in this point right here. Okay, 0, 8. And if I do that, 4 times 0 is 0, 8 times 5 is 40. So the first one I tested, I got 40 in the objective function. Let's do the next one. 4 times the x value is 6, plus 5 times the y value is 5. Oops, 5 times 5, there you go. So 4x plus 5y, 4x plus 5y, 24 and 25 make 49. So when I plug in 6, 5, I got 49. When I plug in 0, 0, I'm going to get 4 times 0 plus 5 times 0 is 0. Okay, it makes sense that if you don't do anything, you get nothing. That's the deal. And the last one, 4 times 7 plus 5 times 0, 28 plus 0 is 28. So which one's the biggest? The maximum is right there. So I'll say the maximum that you can get in the objective function is 49, and that happens at 6, 5, when x is 6 and y is 5. The minimum is 0, and that's at 0, 0. Again, if you don't do anything, you should expect to get nothing. Okay? So you graph them, you find the overlap, and what you're looking for is the vertices of the overlap. Once you have those vertices, then you plug them in to the objective function, and you see which one is the winner. There's no context yet. It's just a bunch of arithmetic for now. Let's try another one. So we've got x is greater than 0, y is greater than 0. That's pretty common. We're talking about the first quadrant, okay? If you're building something or you're doing a word problem, most of the time, you're going to deal with positive numbers. So they're basically saying you're not doing negatives. Okay, x and y are positive. Let's get the other ones. Y is greater than or equal to 3x minus 15. Okay, and again, I think it helps to kind of hide these as you're working. It's just make sure to look at each one. Negative 15 is the y-intercept. 1/4 x plus 4. Y is less than or equal to 1/4 x plus 4. Okay, so the y-intercept is 4, up 1 over 4. Y is less than or equal to negative x plus 9. Y is less than or equal to negative x plus 9. Okay, all right, so we got those guys. We need to find the feasible region. I can see, okay, let's see. Right now it's this, and then when I introduce that guy back in, it's these points. Nope, not that one. Okay, try again. Yep, so right here, there, oh, there. Maybe I need to have these clicked. There we go. That's the overlap of all of them, and it's got to be the overlap for all of them. Okay, let's make sure when you look at that, it's kind of tricky. So we know it's got to be positive. We want to go to the left of this black line, below this red line, and then to the left of this blue line. So yeah, it's that guy. Okay. So we got those points. Those are the vertices of our feasible region. I'm not going to list them again because you can see them right there. But now I will type in the tests because now we haven't looked at this guy at all. That's the objective function. Now we're going to use those points. So 4 times 0 plus 3 times 0. I'll start down here. Okay, that's 0. That's the minimum. 4 times 0 plus 3 times 4. That's this guy. If I plug in that guy, 0 plus 12 is 12. 4 times 4 plus 3 times 5. I'm plugging in 4, 5. So 16 and 15 make 31. What else do I say? I need to 6, 3. 4 times 6 plus 3 times 3. 24 and 9 make 33. And then the last one, 4 times 5 plus 3 times 0 is 20. 20 plus 0 is 20. So where's the maximum? The maximum is 33. The biggest one of all of those numbers is 33, and that happens at 6, 3. And again, the smallest is 0, which is 0, 0. If you're trying to start a business, the moral of the story when you're doing these is if you do nothing, you will get nothing. If you do 0, 0, you will get a 0. Okay. One more. Let's graph them in Desmos, but here it's not zeros. We got to pay a little more attention. X is greater than or equal to 2. Okay. y is less than or equal to 7, so less than or equal to 7. Okay, we're talking about smaller numbers now. I'll get rid of these. So greater than 2, less than 7. So right here now. And what else? Y is greater than or equal to x minus 2. Y is greater than or equal to x minus 2. Okay, so right now we're looking at this as our feasible region. Greater than 2, less than 7, and then above that line. And then negative x plus 10. Y is less than or equal to negative x plus 10. Okay, so where's the overlap for all of them? Whoa, come back, Desmos. Here it is. All right. Let's see. This, that. That is the feasible region. That's the overlap for all 4. Can be kind of tricky to find. If it helps, kind of look, okay, to the right, all right, underneath. So that's why those are getting boxed off. And then up here, that's green, and purple just chumps that guy right there, okay. So we got our vertices right here. So you can see the vertices, 2, 7, 3, 7, 6, 4, 2, 0. Now I just got to plug in the vertices to test. The objective function is 6x minus 5y. So 6 times 2 minus 5 times 7. 12 minus 35 is negative 23. Ooh, negative numbers. Okay, all right, whatever. 6 times 2 minus 5 times 0. I'm plugging in 2, 0 right now. It doesn't matter what order you do them in. That's 12. 6 times 3 minus 5 times 7. So 18 minus 35 is negative 17. Another negative, okay. And then the last one, 6 times 6 minus 5 times 4, 36 minus 20 is 16. So if I want to maximize the objective function, the largest of those is right there. The maximum is 16, and that happens at 6, 4. And if I want to minimize them, the smallest is at 2, 7, and that's when you get negative 23, 2, 7. Okay, so we got some negatives in that one. Doesn't matter. You're playing the same game. You graph your constraints, you test the vertices, and then you use the objective function to determine which one is the max or min. So we're going to continue this. Make sure you've gone through this, you get the idea, and make sure you hit that like and subscribe.